Hi, I'm J Thomson, a British physicist. In the atom world, I am the one who discovered the electrons by conducting an experiment designed to study the nature of electric discharge in high vacuum cathode ray tube. I'll explain in detail how it works later. First, let me talk more about myself. I became a physicist by default. In fact, my father intended me to be an engineer, but because it couldn't raise enough fee, I attended the Owens and Trinity College and became a mathematical physicist. In 1884, I was named to Cavendish Professorship of Experimental Physics. Although I was clumsy with hands, I was quite good at designing apparatus and diagnosing its problem. I encouraged students and tried my best to be a good lecturer. Now, back to my theory. Using the cathode ray tube, I put forward a new theory that atoms are not indivisible as it means, that they are made up of smaller particles. Scientists before me had already done many experiments to find the structure of the atom, and they all had experiences with cathode ray tubes. When an electric current is passed through a vacuum tube, a light will glow inside the tube, traveling in a straight line, and I suggested that certain particles were coming out of it. So I decided to conduct more experiments using cathode ray tubes. I placed two electric plates on its path. One was positively charged, the other was negatively charged. Then something surprising happened. The glowing light bent toward the positively charged plate. Through experimentation, I observed that these rays could be deflected by electric and magnetic fields. I concluded that rather than being composed of light, they were made up of negatively charged particles. I called them corpuscles, which later became known as electrons. Plus, they are 1,000 times smaller than hydrogen, the smallest atom. This effectively disproved the notion that the hydrogen atom was the smallest unit of matter and proved that the atoms are divisible. This theory helped me receive the Nobel Prize for Physics in 1906. Next, I suggested since the atom is neutral, now that there's negatively charged electrons, there should be positively charged particles as well. To explain the overall charge of the atom, which consisted of both positive and negative charges, I proposed a model whereby the negatively charged corpuscles were distributed in a uniform sea of positive charge. I just considered the atom as a sphere with the positively charged particles surrounded by the negatively charged electrons, and that the electrons were placed there due to electrostatic forces. This model was called plum pudding model. For this, my student Ernest Rutherford and my assistant Francis Aston did some further research.